And we are back. So I hope you managed to relax a bit, cool off, because I took a sneak peek at all of the upcoming presentations in the remainder of the evening, and oh wow, we have containers, we have integrations, and we have our next presentation, which is really interesting. We're going to be talking about streaming Zabbix metrics to big data platforms, and then maybe doing something further with that data. Really interesting and really useful. Specifically, we're going to be talking about streaming Zabbix metrics to Clonai platform. So let's welcome our next speaker, which is going to tell us how to do that. Software Development Manager at Clonera Turkey, Levent Karakas. Welcome.
Hello, this is Levent from Clonera. Today I'm going to be demonstrating you real-time streaming of Zabbix metrics to big data platforms. First of all, I'd like to start with talking about storing metrics in a relational database management system. Relational databases are not the ideal solution for storing metrics at scale. If we think about the referential integrity index mechanisms, it's not designed for storing metrics. With version 4.2, Zabbix brought timescale DB support to, which is included in PostgreSQL database. This brought us 10 times performance improvement, which is really good. It gave us a huge relief. But what if there are terabytes of metric data to manage? What do we do? First of all, I'd like to start by asking the question, who needs to manage terabytes of metric data? The answer for this is the Clonai platform. The Clonai platform is a monitoring solution which serves multiple customers at the same time, monitoring multiple environments and platforms, and creating alerts, aggregated alerts, and provide dashboards, and provides a mechanism for automation. And it's a full-featured monitoring solution which is composed of best-of-the-breed monitoring tools, open source monitoring tools, and Zabbix is the main pillar. It's used in most of the monitoring facilities, and this system is multi-tenant, as I said before, and it has a single sign-on mechanism, and the whole system runs on containers and orchestrated with a CI/CD pipeline. And it has many tenants, and if you have many tenants and if you have many nodes to monitor, then it means it's really very easy to have terabytes of metric data. So a little more about the Clonai platform. The Clonai platform is actually provides a stack for each tenant, and within each stack we have multiple containers. One of them is the Zabbix containers, of course, and it has 3 containers for each stack, or for each tenant in a stack for Zabbix, which are web server, the database, PostgreSQL database, and the server. And beyond that, the stack also contains more monitoring tools in the stack. So what actually it does is for each tenant, we deploy one of these stacks, which means we have hundreds of containers running together in a single monitoring cluster. How can we store lots of metrics? After doing some research, we ended up selecting Hadoop HDFS as a file system, and on top, Apache Druid as a metrics database. We have many reasons for selecting these products. Start with Hadoop. It's really cost effective since it runs on commercial hardware. It supports large data sets. It supports replication. It's fault tolerant. It's highly available. It's scalable, and it has high throughput. And for the metric database as Apache, it's cloud native, and it supports streams and batch ingestion, and it's optimized for time partitioning. It can horizontally scale. It has a flexible schema, and the best is it has SQL support. So, how did we start? Before starting, we need to talk about the types of importing data. So we have two methods. One of them is the batch ingestion, and the other one is the streaming. The batch ingestion is actually importing data in bulk, which is the loading of the files into the system, and this usually happens as a test-based. The files are sequentially loaded in the system. Druid already supports many file formats and file sources, so batch ingestion is an option. And on the other hand, there is the streaming. The streaming works in real time. You stream the metrics like you stream the video or audio, and Druid service ingests directly from these streams and puts them into its database. Our first trial started with the Zabbix real-time export. It's an already built-in feature, so if you enable it in the config files, it supports exporting files, exporting your metrics into files, which can be batch digested by the Druid. So it's good. The file format is JSON, which is good. Again, it's supported with Druid ingestion. There is an option. There is a threshold, file size threshold, and each time the file reaches to this size, then a new file is created, and the previous one is ready for loading. I put the link at the bottom. If you want to learn more about this format, this real-time export, you can check the link. And the second option was the streaming. The first option was to use these files for batch ingestion, and the second option was the real-time streaming. If you can stream the Zabbix events to Kafka, Druid Kafka Index service can ingest them. And the good thing about this approach is that you don't need to manage the files. So the question here is the missing piece in the puzzle. How do we put the metrics into Kafka? Once we get it into Kafka, it goes all the way down to Druid. We started by looking for a module that can do this, and found a module in GitHub called Zabbix History Kafka Loadable module. We gave it a try, we tested, and realized that it's not working. So we tried fixing it with no chances, and then tried writing a brand new one. After lots of debugging, realized that it's not possible to keep librd Kafka state open and then reuse for events, so we gave it up. We needed a new approach. So we found another solution at this point. We decided to use a middleware that can get metrics as web hooks and put them in Kafka topics. So for this, we found two solutions. One of them is the Kafka REST by Confluent, and the other one is Kafka Pixie by Mailgun. And at the end, we end up using the Kafka REST for this task. But we still had a missing piece. That was the web module. How are we going to call the Kafka REST? And that's the Zabbix history webhook module. And we ended up developing this module. Let me mention about this module. It formats and writes Zabbix history to webhook in Zabbix real-time export protocol in JSON that we just mentioned a few slides ago in Zabbix built-in real-time export feature. With one exception is that it doesn't have the item key. We added the item key, and it supports all the formats, float, integer, string, text, and log, and it has a feature for specifying the content type which is needed in some cases, and it has an option for turning off the SSL verification errors, and it can call the webhook per measurement or per multiple measurements, which is bulk mode, which allows us to send more than one measurement with one webhook call. So it's good for performance, and it also supports custom tags in the bulk mode. This is needed for the Kafka REST, and it supports environment variables for using them in containers easily. And virtually, it can be used to export to any system that accepts web push. Again, we open sourced this tool and published in the below link. You can go and check, try it. If you need it, you can use it. So this is the final topology. And in the final topology, the story starts with the Zabbix server and goes all the way down to the superset, which is the dashboard for showing what we store in the Druid database. Each pillar here in this chart is actually a tenant. At the most left, we have the containers, and then they are sent to Kafka REST and written into tenants' own Kafka queue, and then Kafka ingest module gets the streamed metrics and write it to Druid's data source, which goes all the way to Hadoop. And whenever somebody goes to superset for viewing the dashboards, it goes to data source, Druid data source, and brings the data metrics from that Druid database. And virtually, we can each piece on this chart is horizontally scalable, so we can scale as much as we want. Now I'm going to demonstrate the configuration of the whole pieces and give you an example for each of the configuration. And to start with the Zabbix server, what we do is we are using containers, so we are going to be using environment variables here. Each of them has a corresponding config entry in the config file as well. So we need to load the Zabbix history webhook module and then specify the webhook URL and the content type, which is required by the Kafka REST, is this one. And by default, the text and string is not enabled, so we are enabling them here. If you need more documentation, you can check the GitHub link. And the next stop is the Kafka REST. So for the Kafka REST, we need a few parameters. One of them is the Zookeeper URL. This is needed for it to run. The REST name, host name of the REST Kafka, and the port and interface of the listener. So this port was actually in the previous slide. Zabbix is pushing its metrics to this port. and then it's been written to the host name at the top. If you need more information, again, you can check the link below for more information. And the third stop is the Kafka itself. Again, we gave the Zookeeper port and host name, and then we have the advertised host name. This is the host name of the Kafka, and we specify the port and listeners option. And here we have log retention hours of 48 hours. And next one is the HDFS configuration in Druid. So we need to enable HDFS in Druid. How we do that? We need to install the HDFS storage extension. We open up the common runtime properties file and put the Druid HDFS storage option as an extension and specify the storage type as HDFS with the URL of the Hadoop. We're not going into details of setting up Hadoop. You can always use your favorite distribution of Hadoop and just put the URL here and it's ready to go. If you need more information, as always, you have the link at the bottom for the HDFS configuration in Druid. Next, the Kafka indexing part. Again, another extension to be enabled. Here we have the Druid Kafka indexing service to be enabled. You can see it in bold. And as always, if you need the documentation, it's right at the bottom. You can check. And finally, once we're in Druid, get it up and running. What we need is how to enable the ingestion. So how do we do that? First, we select the Apache Kafka and put the server name and the topic name here, and it automatically grabs some data from the queue. And then if you click on next, it becomes a table. It's parsed as table with all the metrics inside. And then after a few next clicks, you end up with a spec file. The spec files can be used for quickly creating these data sets and tasks. Once you have a spec file, you can easily modify it and reuse it. Even you can use it in automation. So when you confirm and submit this, what Druid does is actually it creates a supervisor for this task, and it creates some tasks so that this task goes to Kafka topics, and then gets the metrics from the Kafka queue, and then ingests them and writes them in the HDFS. So you can see the successfully finished task at the on the list, and at the top there is a running one as well. And this is the data source that we are creating. It already has 1,801 segments with 24 gigabytes of data ingested already here. And to use this data in Apache Kafka, we need to make a small configuration in Superset to create a data source for Druid. We use the SQL Alchemy URI. Here there's an example for that. We use the Druid host name here. And finally, what we have at the end is the same graph that we have in Zabbix, finally in Superset, streamed in real time. So this is the final slide of this presentation. And before finishing my presentation, I'd like to thank the development team that made this project come alive. there. Thank you. And also, thank you for watching my presentation. Have a nice
Thank you, Levent. That was quite a nice presentation. We do have a couple of questions for you, so get ready to answer them. So first off, have you ever considered using Zabbix with Elasticsearch and Kibana?
Actually, that's a good question. We during the expert course, we learned about using it with Elasticsearch, but it was not really recommended. So we didn't use that after that course. So we haven't used it. But we are using it for streaming some other data, some alerting data into it for some analysis. So we are using Elasticsearch as well. Yeah.
Yeah, good to hear. Even though it's not recommended, it's still, I think it's a good practice to use it in some sort of a test environment and see maybe there is some beneficial use case, and then you're free to use it. So it kind of depends. What we recommend from our side is first just essentially testing it out, how it works for you. And if it works good, then you can use it in production together with some other software maybe.
Yeah.
Then we have another question. Can Druid ingest default Zabbix JSON export format, or do you need to reformat it in some way?
It's ingesting it as it is. The only thing was to add the item key because we needed that for filtering out. So the original output JSON file doesn't have the item key. So that might be a problem, but if you use our module, we are also adding that key as well. So it works quite well.
Yeah, so idea here is to use your module and then everything is pretty much set and no need to kind of reformat it.
Yeah, actually, we are using the JSON format, which is 99% compatible, almost the same file, with the exception of that single addition. Yeah.
Yeah, thank you for letting us know these technical details. They're really useful for people who decide to maybe test out the solution in their own environment and see how that works.
Sure.
Thank you. That is all for now. Once again, I'm going to say what I said for other presenters. Q&A section is where you can ask your questions. And my guess is that Levent will be there and will be ready to answer your questions and help you out with maybe implementing this solution in your own environment or just answering general questions. Thank you.